Okay. um, at the beginning, both Stefan and me have some needs, which was time series. And we both have largely discussed about what we are using Warp 10 as a database. So this is not the talk we will done today. And if you need any talk about that, it's plenty on the internet. This is not the point. We choose Warp 10 because of many features. We will give you some insight about how it works and some return on real use case. But we will not discuss all the feature, and there is feature we never used, even Steven or me. So it's not a full like 101 of Warp 10. If you need this, just ping Matthias Herberts on Twitter. What's the real problem about time series?
Well, time series is a special kind of data because there is a really antinomic pattern between writes and reads. For example, when you write your data, most of time series use cases are actually monitoring or IoT, but all data come at the same time. So you write them tick by tick, but when you read them, you actually scan per dimension. So maybe you are focusing on one device and you read 1 year of this device. So the pattern is really opposed between how you write the data and how you read. I don't know where you are. This is not a slide. Okay.
I try to hide this. I don't know how to hide this. So if someone know how to hide this, I'm fully, it will be okay for me. Okay.
So once we know that we have to get the data inside, you have to accept actually different environments, etc. So what we did at OVH, we built different connectors, different proxies to actually accept everyone in different environment. And for example, if someone used Prometheus or Graphite or OpenTSDB or whatever, we have all those connectors to accept them natively, and we ingest the data.
So basically what's interesting with Warp 10 is we have many connectors to ingest the data from outside without to be in the Warp 10 world. And the other point is when you choose a time series data for any monitoring, can be business monitoring or actual infrastructure monitoring, one of your problem is to unlink the write path and the read path. Because you will write a lot of data all the time, and any complex reads or any complex operation you will not have to affect the way you just dumping data inside the data lake. Because if, for example, you have a very complex read who block the ingestion system, you will have many cascading problem from there. So an important point is the ability with Warp 10 to unlink the write and the read path, to write concurrency, and to have concurrent read. And it's designed to have micro batching, because many of your data reads will not be acting on the stream, but acting on the data from the past hour, from the past 7 hours, from the past days, or for the past years. So the important point is not the stream management, but the micro batching ability to act on the data with the old data.
Once you have the data, there is a common issue with time series is cardinality. Who understand what is cardinality? Okay. The cardinality issue is that when you create a new time series, it's qualified by mainly a name, which is the metric, what you measure, and dimensions. But once you have created many of them, if you need to aggregate them at scale with millions of time series, for example, you can have issues on this because of remind the anti-pattern between reads and writes. So there are different strategies to tackle this issue. And at OVH, we have what we call a multi-stage time series infrastructure with in-memories and more cloud or persistent time series for long-term retention. So on the in-memory, we are able to aggregate multiple millions of time series at read and at query time. Why do we do this? It's because the cloud infrastructure is mainly multi-tenant. Since it's multi-tenant, we cannot be more very aggressive on the capacity to aggregate on cardinality. Because if it's full power for everyone, we will crash the platform, and or it will be very costly. So cardinality is an issue, but thanks to Warp 10, we have solutions.
Another point is Warp 10 index have the ability to be extendable. So you can have what we call a directory plugin, which is able to send all the metadata of class attributes and all the definition of time series to somewhere else. For example, Elasticsearch. And using that, you will be able to autocomplete on class to use the Elasticsearch to query the metadata of the system. So the interesting point here is, at its directory plugin, you can plug in nearly anything you know to just have the ability to understand the metadata layer you have, okay? The second problem we have is query the data. Basically, majority of time series system we know out there are just system where you can sum, you can have average on the window function, and that's all. And the problem is, when you grab a lot of time series data, you will have a lot of data manipulation to do on top of it. And the data manipulation can be very complex and very costly in terms of performances, because you will have to take a lot of data from outside. Warp 10 is based on HBase, and HBase allows you to execute function on top of the data. So directly on the data node. That's why there is more than 900 function inside Warp 10 helping you to shaping the data where you want and processing the data directly on the node having the data, and not giving you the obligation to stream the data to a worker elsewhere.
And it basically avoid the fact to load the data and program or build some code to process them. And it's an interesting point, and because mainly when you have business issues or challenges, most of the time you actually don't know how you need to process the data. And the Warp script library comes with 900 functions, but purposed. For example, if you need some downsampling strategy, filling strategy, etc., it's all there.
And the point is, there is several proxy at OVH for the query?
Sure. How we did for the ingress pass, we did the same for the query pass. And so we can query the OVH metrics platform with Prometheus, which is called PromQL, Fight, PromTSDB, Influx recently. And we are about to open source this. So it will be announced in the next Paris open source time series meetup. But don't say it's a surprise.
Majority who know already Warp 10, but never using because of Warp script. Because it's sometimes when I hear people speaking about Warp 10, they say to me, yeah, but the point is there is Warp script, it's very complex. If your job is to manage time series data all the day, invest one day to understand how to query it, seems a good investment. And I don't understand why a lot of people are speaking about technology just reading the hello world example and saying, oh, seems too complex, never tried it. If it's a major use case for you to understand it, just invest 1 or 2 days to really get inside the use case of the data, because it will be a good investment. When you tried Hadoop the first time, it have been complicated. So it's the same thing here.
Even though WarpScript is a fabulous library, we have customers that actually don't have special needs. Maybe just need a dashboard with few graphs. So we needed something with the clear semantic of WarpScript, but with a lighter language, easier to access, etc., more developer friendly. So we created something like called TSL for a time series language. No? Yeah. So here is a simple example. You select a metric, you filter with tags or dimensions, where are key value. You select the window you want to read. For example, here last 1 hour, and you sample by. Sample by is just a downsampling aggregation. The aggregate maximum and for 5-minute buckets. What's really interesting here is the semantic is really clear, because when you deal with time series and aggregation, you need to aggregate them tick by tick, and you need to align the ticks. If you worked with Prometheus, for example, there is a magic thing, and you don't understand at all what you're doing. And it's a real issue, because if you deal with monitoring, Prometheus can be okay, because it's mostly working on the last value. If you're working on, I have battery issues. Okay, I have to switch with yours. If you're dealing with more generic time series, for example, IoT, billing, whatever, stateful time series, well, you can't mess with your logic, okay? So you have to clearly understand what you're doing with your time series. So here is a simple example. We have plenty of others. I won't get into too much details today, but for example, you can have strategies about how you fill your data when you're downsampling, but there is no point in one of the buckets. This is kind of things that in real life are really important, because it depends on the business case, but it's really impactful. So there are plenty of examples. You can go to GitHub/OVH/TSL, and you will have a documentation for all this.
And more, TSL is not working only for Warpton, but also for Prometheus, for Influx, for
no.
It's kind of ORM for system.
No, for now it's just WarpScript and PromQL. It acts as a proxy for them, but we have great plan for TSL to be a full-featured query planner, so you can push any time series database behind, and you will have the full feature of from TSL.
And there is also an integration with Grafana, so you can just add TSL to your Grafana, and you will be able to use it in actual project if using Prometheus or WarpScript. One of the interests of Warpton is the modularity. Basically, it's our Warpton function. To be clear, you basically have one jar, which is only one jar, and you launch it with several roles. So you have the ingress, you have the directory, you have the egress, you have all the system who actually power your Warpton cluster. And if you want, for example, to have quality of service guarantee for several of the stuff, you just have to create an egress cluster just for these services, and have another cluster of egress for services with less quality of service. So one of the interesting points there is you can scale and manage each component of the Warpton cluster separately to be sure that there is no problem between the cluster. The other point is it's very simple to add some component there because there is now something called Warp Fleet. We give you the ability to use all the plugins we are talking about very simply because you just install it with Warp Fleet and it's scheduled inside the Warp 10 cluster very easily. So it's very simple to extend the capacity of the Warp 10 platform. So some real use case. There is the slide with problem. So the slide with problem is this one. I don't know if you see it, but you have all the points on the map where there is actual HTTP requests. So it's a new feature we have at Clever Cloud. Is every point will be analyzed. So every time you enter inside the HTTP system from Asha Proxy or Sezu, which is our homemade reverse proxy, the access log will be forwarded to a complex system with Pulsar, and we have a serverless system inside using the Pulsar function, and it aggregates all the data inside Warp 10. When you want to display to all your customer every request they have, you cannot just forward them the access log. Because if someone has, for example, 10,000 requests per second, you cannot forward it to the browser to show it on the map. It will be a performance issue. I think the browser will not be agree with that. So you will need to aggregate the data on the location and micro batch on several stuff. Very easily to do on Warp 10 because Warp 10 will manage the micro batching on the geolocation aggregation, and we will be able to using that thanks to a new feature of Warp 10, which is the multi-value point, which is another point very interesting in Warp 10. When you record a data point inside Warp 10, it can have many values. So you can have a data and a text and something else. So it gives you the ability to store a log, for example, directly inside this, which is really interesting. And you can have long-term storage inside an object storage. Another point is the architecture of Warp 10 gives you the ability to plug a cluster of egress in front. So user can actually, if you give them a token, directly query the Warp 10 cluster. So basically our front is just querying the Warp 10 cluster directly, and the Warp 10 cluster is making the aggregation and everything, which is a far simple way to manage this whole complex problem. This is another usage of Warp 10 at OVH.
Yeah, so we have a very big infrastructure with 30 data centers, 35 pubs. I don't count them anymore, actually, but we monitor all the things, applications, products, customer products also, and everything. So at the point, we aggregate this and we have specialized regions, but the global internal regions for the overall infrastructure monitoring is seeing 3.5 million queries per second. So it's an overall, but you have 1 million per second reads, queries, and 1.5 for writes. It means we take nearly 8 gigabytes per second of data continuously, because you can, I don't know if you can see the graph, but it's merely stable. It also means it's 6 million data points per second. For this kind of thing, we also benched the ingress path of Warp 10 using an in-memory, specialized in-memory. So we clocked it at 120 million data points per second. So we are good, no real issue on this. And we manage more than 600 millions of unique time series. One specialized use case of Warp 10 on the infrastructure is for IPME. If you don't know what IPME is, it's a specialized protocol so that you can monitor a server but without having access to the server. Okay, it's more something that an operator will use, but not you. So here is an example. We raised a few alerts on the last year based on patterns. For example, if we have a 30% raise of heat per rack, a rack is an ensemble of machines, then we issue an alert. And there is no issue for customers, but maybe they will. So the thing is, we can detect if it's based on maybe a water cooling issue or a heat that is not evacuated properly or things like this. So we can act before there is actually an impact. Also, okay, I don't remember what I was saying. I had a surprise and I didn't put it. Okay, too bad. Next. So there is.
Yes, the problem is always to predict the future.
Yeah, we can predict the future and how to do it with different strategies. For a simple example with memory, here is a small graph showing the memory consumption of a process, and you see the volume of memory consumed. But since it's memory, you have a physical limit on the machine. So here is the limit of 32 gigabytes. And we see that there is a leak. Yeah.
You are going full speed in a wall.
There will be a problem here. And I think everyone is seeing it. So what can we do at this step? We can extract the trend from the signal, and we can forecast it. So here is the crossing lines. The issue is here, but we can act before because we can detect that we will hit a wall. And you can have different forecasting strategy because you can forecast a trend, or you can forecast the signal by itself. Here, it's a matter of business case because you see that show crossing is not the exact same time. And when you cross, next please, what do you do? Well, it's up to you to decide. You can do a graph, for example, in a dashboard, or you can alert, or for example, you can scale a service. If it was based on maybe a request on a load balancing service, well, we see that we hit the limit of the load balancer and we need to scale it automatically. So we can pre-scale the service instead of being reacting on the load, okay?
But so this was majority of the forecasting you just show is majority statistic and based only on warp 10, but it's majority signal management.
Yeah, but how you told it before, but one interesting thing is just previous slide, please. All this is just a simple query. Okay, you don't have code on your side, etc. You just get a signal, treat the signal, express it in warp script, and it's a single query that manages all this.
It's just warp 10. There, it's just warp 10. Then you jump to another capacity you develop, which is the AutoML.
The previous one was just based on linear regressions, and it's pretty simple, not rocket science. Here is a different strategy. Maybe if you read a lot of literature in the last year about time series, there is a lot of things for time series. At OVH, we are creating a service that is called Prescience, which will be open source soon. It's actually testable as a managed services on labs.ovh.com. And you can predict the time series based on training. So you have your historical signal, you train a model based on it, and you will forecast it. It's a very big deal because when you forecast time series, you can have seasonality in there. And maybe you can have seasons inside a bigger season. So if you don't train thing, you can't really forecast something that has value depending on the case. So how it works?
Yeah, because I wanted to show to the people how simple it is. When you launch Prescience, you're just saying, okay, I have a data source. It can be a file with basically CSV data value, but it can be also a time series source. When you're using a time series source, you are basically using something very simple, which is just giving a warp10 endpoint and a warp10 token. And then you will be able to launch several machine learning drones. We will try a lot of different algorithms on a sample of the data and see how the trends are going, resampling the data.
Yeah, what's interesting also is that behind there is computation with different models, different algorithms, and the solution can select the best score in different algorithms for prediction.
So it selects best algorithm and give you the information about the accuracy of the system. Very simple to use, very interesting, and will be soon open source, and you can just use it right now.
Yeah, we will start with the serving layer.
And it's used by your team internally?
Yeah, the first use case was actually to prevent some fraud, because we are seeing a lot of fraud on infrastructure, some people that are buying servers to attack other, etc. So the first challenge was to prevent them from frauding our service. So we have to detect frauders based on patterns, behavior, etc. So this project is based on this, but we actually build it as a platform, as a service, so that others in the company can build their own experience based on the same infrastructure.
And from a Clever Cloud perspective, what we do using the warp10 is to use the machine learning stuff to manage the scheduling of the infrastructure. So we are not scheduling the infrastructure like, for example, Kubernetes saying, oh, since I have some rooms here to put a new service, I will put it. We use actual consumption of real service to put it in a good shape with all the service, which is far better a good idea, which is not reacting on issue, but just have a plan and make the plan work. Another great usage is else. It's something you create at Brest.
Yeah, we work with gynecologist. Okay, yeah. So basically, it's a doctor that work with pregnant women, and he monitored. He has the world's biggest database with women monitoring when they are pregnant. And his challenge was to work with perinatal mortality. He found he had a thought about maybe when you sleep, when you don't breathe when you sleep, and he thought maybe it's linked to this kind of thing for the delivery of the baby. I don't know the exact term, but and it was really visual. He told us, okay, I have this thing, and this thing, it's there, but I can't find a model. And he worked for years with mathematicians to work for the mathematical model. And I thought, okay, but I don't know your problem. I don't know the math, the model or whatever, but you tell me it's just working like this. Okay, so I will downsample your signal, define it with pattern matching algorithm, and then we can find the pattern on the signal. And we find them. Pick. And it was funny because it took us one afternoon, and he was working with best mathematician for years. Yeah, we can actually save babies based on this kind of things.
Another great usage is Hello Exoworld, which is the ability to discover exoplanets from Kepler and TESS dataset. One interesting thing is all the Hello Exoworld is open source, So it's a very interesting project if you want to enter inside the Warp 10 world, because it's, you know, it serves a real use case out there. Basically, the data set for Kepler is 40 billion of FITS file, which is 25 teraoctet of data, which is just pushed on overhead metrics. And for now, for Kepler, they try to find if they find exactly the same planet than the NASA, and they try to use the same algorithm on the test data, which is 200 times bigger than the Kepler data, and which is actually fun. I just discovered when I do the slides. It's Hello Exoworld is basically managing all the stuff on top of Clever Cloud Platform as a service and using the OVH metrics. Basically,
cool,
our
right?
two products. So, what's interesting with Warp 10? It fits very well inside an Apache big data ecosystem. So you have integration with basically every Apache big data project, LastSpark, Storm, Flink, everything. You can view stuff using Grafana. You can send the data using Jacob. It's very well connecting system. And I wonder, after this presentation, how many people I have convinced to try out this technology? Not enough.
3, 4, maybe some shy, maybe.
Okay.
Just the previous one, because it's actually cloud native also.
Thank you for listening, and we're here if you need anything. Thank you very much.